Today I will present mostly my updates on my work in my PhD. The first part of my PhD is about intonation analysis, and that's what I have been presenting in last couple of workshops. But this time I have been working on mainly enhancing the data structuring mechanisms in CompMusic using ontologies and semantic web infrastructure. To give a broader context, this is my PhD topic, which is about developing knowledge-based similarity measures for music. And as I said, the first part is about audio description, and the part which I worked on is intonation analysis. And the second part, which I will be talking about today, is building ontologies. And the culmination of all of this work is in building similarity measures for navigation, the navigational tool which will be introduced by Alastair after the coffee break. So I will shortly introduce the current data structuring mechanisms which we follow in CompMusic, and also that by the data sources that we collect from, and then present the necessity or the need for knowledge representation for Carnatic music. Then I will explain the reasons of selecting ontologies for knowledge representation, and then present my work on developing ontologies for melodies in Indian art music. I'll shortly present, very quickly present some application scenarios which will be expanded by Joe in later this day, and also some future work. Okay. As Xavier mentioned, the main data sources which we are using at the moment are the audio features and Wikipedia, kacheris.com, and MusicBrainz. Most of the data which we use for Dunia, which is the browsing navigation tool, is in relational databases. There are some, most of the features which we see today in Dunia are developed from these relational databases, but there are some limitations to it. Few of them are these different data sources. They use varied and incoherent vocabulary. By that I mean that they use same description. For example, take an artist and they have different ways of talking about that artist. Kacheris.com says the same thing using different vocabulary than Wikipedia. And more than that, we don't have a description for a field about a concept. For example, about a rāga, if I say if this rāga has a Swara, and a Swara is nothing but a column or a row in that table, and it's a bunch of characters, and it doesn't have any meaning to it that is easily processable by a machine. And further, like if I need to integrate different sources, multiple different, mainly different types of sources, more than different sources, then I need to develop some ad hoc and complex linking procedures that are not understood by another researcher. And the insights and a consequence of this, the complex linking processes, is that all the insights that are easily obtainable when we see all these sources together are hidden. I mean, if we don't see the joins which are not obvious in a relational database, we miss those insights. So our goals to advance the current data structuring mechanisms come in two ways. One is to have machine-ready descriptions of all the concepts, all the core concepts. By machine-ready descriptions, I mean these descriptions should carry semantics of these concepts. So I will explain what these semantically rich descriptions mean by in explaining the rāga ontology, which we will go on later. And the second part is linking these different types of data sources. For example, the intonation analysis which we have developed, it says something about a recording, but there is no easy way of linking that to other different sources of information like Wikipedia or the editorial metadata. So for this we need a coherent vocabulary, which again comes from an ontology. So in this presentation I will mainly talk about the first part, which is providing machine ready descriptions of these concepts. So before that we need to identify what concepts do we need to describe. So as Xavier mentioned, melody and rhythm are the very core concepts that we are addressing, and other aspect of Carnatic music which is important is forms. And in melody, the three main concepts that we consider for developing these ontologies or descriptions are Swara, Gamaka, and sequences. And one way to cross check that our ontology will cover most of these concepts within the melody is to check if it addresses these different classification schemes that are relevant for music in music literature, which is relevant to current practice. And the two concepts in the rhythm that we would like to address in ontologies in future are metrical cycles and their substructures. So over the last decade, we have, especially due to biomedical domain, we have seen an explosion of ontologies which are of use to general research, not specifically to the biomedical research. So, and this has pushed the boundaries of semantic web technologies, and it resulted in really expressive languages with powerful reasoners, which include RDFS and OWL with many of its variants. And also with this came the linked data movement, which is to advance the web to the next stage, which is to say that at the moment the web is for humans, and in the future the web should be for machines. If you want to do a task, you should not need to go through multiple sources to find all the information that you will need. So a machine should automatically be able to do that. And one way to do that is to link different sources of information using coherent vocabulary. And essentially we take advantage of this infrastructure that so far developed for advancing our data structuring. And in doing so, we will be also providing a platform where we can share the knowledge, and it can be used by other applications to communicate among themselves. And also in our audio analysis, there are different models of a same concept. For example, like there are many people working on motivic analysis. If we have a coherent vocabulary about the sequences and the rāga ontology, it becomes really easy or systematic to compare and integrate those different models of motives. So that's the background about knowledge representation, like the necessity for knowledge representation in the context of CompMusic. Now I will briefly present the rāga ontology which we have developed over few months, and also present some application scenarios. So as I said, the main concepts that we take from rāga to develop an ontology are these three, which are taken from a paper by T.M. Krishna. Are these swaras, gamakas, and sequences. So, I assume that most of you know these three, so I'm skipping this slide. So we start with a swara, and we know that there are 7 types of swaras, which become subclasses of these, and for each swara has 2 or 3 variants, and each of these variants again have properties defined within them. So for example, all the 3 variants do not occur in a sequence or in a rāga, so they are disjoint with each other. And there are properties defined with the variants of other swara. For example, Shuddha Gandhara should always be preceded by Shuddha Rishabha for a raga, in a raga, if both of them occur in that raga. So the Swara ontology, it covers all of these Swaras and their relations between them. Basically, this is a graph representation for us, but there are owl serializations like this is an XML serialization of whatever we have seen in the previous slide. So once we have this Swara ontology, the next thing to go about is the sequences. Owl doesn't have its own vocabulary defined for owl, by the way, is a web ontology language. Sorry, I did not define it earlier. There is no vocabulary for defining a sequence within owl. So we take an ontology developed outside the core owl vocabulary and use it as a sequence. This owl list is being used for DNA sequences. And we define a progression, which is Murchana, and a Gamaka as a sequence. We defined Gamaka as a sequence, and I will explain that later. And progressions are of different kinds. So when we started working on defining Gamaka for this ontology, it has been a big task to find the proper boundaries of the Gamaka, and there is no agreement on that. So what we chose to do instead is to find a sequence where this Gamaka occurs and say that this is a sequence and this is also the Gamaka, but the sequence has the Gamaka. And in doing so, our intention is to use this representation and in combination with some audio processing technologies to later identify the broader definition of that Gamaka. So this is a way to do that. So we associate this particular sequence to a audio segment and later use audio processing technologies on that. And this is the complete ontology of the raga. Can you see the pointer? Okay. And the raga has some additional properties like functional roles of the swaras and the kinds of progression it has and so on. So we define all those properties, and the raga ontology is more or less complete now. So as I said, one way to evaluate this ontology for its coverage is to check if it is able to cater to this and classify according to various schemes that are there in the literature and are relevant in the current context. The first one is Malakatta system. There is no way to do this automatically, since it's done manually, and so those classification schemes which have a logic associated to them can automatically be done with this ontology. So for example, linear or non-linear, Vakra or Krama ragas. So this can be handled automatically using the ontology, and I will show how in a later slide. So these are other classification schemes. So we do all these classifications using Sparkle rules at the moment, but we choose to replace the owl list and Sparkle rules with owl's own vocabulary defined for sequences in the future. So for example, in this rules, you see that it's a Vakra raga if Rishabha follows Gandhara. So that's what these two clauses check. The main application of these ontologies and all the knowledge representation work we do is to develop similarity measures for navigation. Right now, for the Dunya, which is the navigation tool, uses audio similarity for similarity, and we wish to enrich this using the ontologies. And another area where we wish to apply the ontologies is to in the audio analysis itself. For example, in intonation analysis, we have some results, but we don't have the expertise of a musician to infer what that result means. So if we combine the knowledge or the semantics of that are encoded in ontology with whatever we obtain using audio analysis, then we saw already that we can infer new facts. And of course, in motive detection, it will be useful in supervised learning and also knowing functional roles of swaras, and also cross-checking whether the results obtained from audio analysis are coherent with whatever we have in the ontology. And another area is mining knowledge from the web. So there is this very nice forum called resicus.org, and Joe is working on that, and he will present his work this noon. And the aspects where this ontology will help there is to bootstrap the named entity recognition, which is very crucial part of web data mining, and also using so basically it's two-way. There is this Wikipedia information and there is this ontology, and we can check the coverage of ontology by assuming that Wikipedia has fully covered Carnatic music. We can check the coverage of our ontology comparing it with Wikipedia, and also we can use Wikipedia to enrich and add more properties and more concepts to our ontology. And yeah, as I said, the main goal is to develop similarity measures for navigation, and also the work with Joe. And we are also building ontologies for rhythms and forms. And the final goal is to have a data repertoire with multiple data sources, different kinds of data sources. And a minor thing that I might replace in future is this OWL list with maybe OWL's own vocabulary for sequences. And these ontologies are available online on GitHub, and there are many collaborators right now within us, and we welcome you to join us and collaborate.